So weather is the bane of the astronomer's existence. And a lot of weather systems out there, even for the pro-am community, assume that you're in a pretty good site and you only need a couple of things to really keep your system safe. So professional astronomy sites I'll leave on the side, but for a pro-am site, perhaps we have a weather monitor of any variety, and it has a sky IR meter and a rain meter, which is the two most useful functions of those weather kits, and temperature, wind, humidity, etc. Uh, that's pretty good. If you have a pretty pristine, predictable site, then maybe that's all you need, but it's still very unlikely. Why? Because those kits have a rain sensor on them, but by the time it goes off, your telescope's wet. And there's no guarantee that the cloud meter, which measures clouds all right, but not actually perfectly well, will actually detect that there's clouds carrying water in them floating over your observatory. So you can't just rely on a weather meter. And we have telescopes all around the world in various different locations. So you have like California, which is sunny a lot of the time and cloudy and June gloom some of the time. But it's also prone to storms. So they have a desert area, wet Pacific area, and sometimes storms just come out of nowhere to surprise you and rain on your telescope. We have New Mexico, also clear most of the time, 10% of the time, lightning all around, storms, wind, gusts, and snow. Then you have the Middle East, where we have a few telescopes, where if you have dust in the air and wind uh, versus glass, quite dangerous. So you don't want your telescope open when it's windy and dusty. And so you can see that different places around the world have different requirements. Here in Melbourne, songs are written about the weather in Melbourne. Four Seasons in One Day by Crowded House, if you want to look it up. It's the most famous one. But we get 4 seasons in one day. So we have multiple telescopes around here because that's where I'm based, in the city of Melbourne, Australia. And because of that, because of the variability of the sky, it can clear up for 2 or 3 hours, and then a bank of clouds can come past for 2 hours, and then it'll be crystal clear, usually after the clouds have gone through. The clouds or moisture in the air clears the dust out, and it's quite clear. So in Melbourne, we get quite clear skies when it is clear, but when it's clear, it's quite variable. So you've got all this stuff going on, and you want to go to sleep and not worry about your weather system at all. So here's an example of CTIO, and I've got a few other examples to go through, of how our weather system works and what it responds to, and what you need. So CTIO is in Chile. From this information here, we can get from a local weather meter, or we can get it from the forecast. So some weather meters you get the IR and rain, usually temperature. That's the three core things. Some models, that's all they have. Other models have wind and stuff. So if you don't have wind or dew point or whatever, or humidity on your local weather station, we can get it from the forecast, which I'll talk about in more detail in a minute. But we have local temperature, atmospheric pressure, humidity, dew point, sky temperature is what those IR meters read. That's also another story for soon. Wind, whether it's raining, which is an on-off function. This rain rate is to do with your local weather station on-off, whether it's raining or not. Whether snow is expected. So if it snow's coming, then you don't want to open your observatory whether the sky is clear or not. Frost risk, what risk is it that you're going to get a tough icy coating on your telescope if you leave it open. Then we have air quality meters. So we're talking about the dust in the desert. The desert in the Middle East, the skies are very clear of clouds, but there's always an amount of dust in the air, and sometimes it's worse than others. So we have air particulate matter as well. So you see, we're in Chile, so and up in whatever 10,000 feet or so. So air quality is good. And so makes a judgment, safe to open, yes. So the weather report, so we have an agent that runs usually on the site on a separate computer to telescopes, although it can run on the telescope computer if needed, if you just have one telescope set up. Every night it will make a weather report of what it expects to happen for the night. And it will keep updating this weather report hour by hour to predict out ahead what's going to happen. So we're in Chile, 0% cloud, super duper conditions. Rain risk percent, seeing is an estimate of how good the seeing is. Of course, we're in Chile because it's up near 100. Dew risk, very low. Actually, that should be lower. You're not going to get dew up there. Frost risk, obviously 0. Transparency, fair. Clear sky, etc. Okay, so, and how much snow. So you can see here, it's going to open at this point. We'll see some other examples where it won't later on. So here we have a diagrammatic kind of explanation, visual, that you can see what's happening for the next 4 days. You have red is midnight, so that's showing you where midnight is on each day. Yellow is sunrise and sunset. So you're sort of looking to either side of the red to see if it's clear during that evening. Green is obviously good, red is obviously bad, so there is some bad weather in Chile coming up. And if it's green or blue, it'll open. Yellow is borderline, orange and red, it shouldn't open or observe. I've got a few more lines here. How dark is it? So it's a combination of the sun and whether the moon's in the sky. So you can see the moon is moving out of the sky there. Amount of clouds, transparency, seeing, wind, humidity, temperature, and air quality, like the dust meter. We also have a breaking up the clouds into total cloud, high cloud, medium cloud, low cloud, fog, visibility, and transparency. So you can get a real good idea of what's happening at your site. In particular, those sky meters, the sky meters don't pick up high cloud at all very well. So in this case, which is conveniently, I didn't plan on this, but conveniently it's showing you that at Chile, on Monday night, there's actually going to be a huge amount of high cloud. Now, high cloud, it can be okay, but a lot of the times it's just that type of cloud that you could see a star through it, but the images are so crummy that it's not worth looking at it. But this type of cloud, that type of cloud is not picked up by your local weather IR camera because they're too high, usually a bit too thin for them to be picked up. So you have this cloud thing too. Then we have this. This is kind of a cloud forecast thing. It's a bit fuzzy. The wind is the direction of the wind. So we're up here in Chile. Clouds over the water, none up here at the observing sites. And wind's going in a direction. Wind may or may not be important to you. Here we have the microwave rain radar. Well, one of the reasons you go to Chile is it's no rain. So we'll look at the rain somewhere else later on. And this is an IR cloud, satellite cloud. So also not a very good example. So as you can see here in Chile, looking good for observing. So let's go to a different site here. Let's go over to South Australia. And I've picked a few different sites that have currently different conditions. So at the start of the night, looking clear, but as you can see, at some point in the morning, 3 a.m., it predicts clouds are going to come. Whether they come or not, this is updated every hour, and it'll make assessments on the hour every hour as time goes on. So you can see here the weather is much more variable than on the top of a mountain, and it's actually going to stay closed quite a lot, mainly due to clouds. So you see clouds here, and it is getting pretty humid. Temperature's okay. So you can see lots more cloud here at different levels as well. So here's South Australia over here is the site. Here's the microwave rain satellite. So this is a satellite looking down on Earth and predicting rain according to what it can estimate from above the clouds, which is actually pretty good. It's lower resolution than a rain radar, but you only need to know that there is rain going over the observatory to know not to observe. You don't need to know it in detail. But here's the rain radar from the ground. So in this one, we've got a few interesting things. So this blue thing here, these polygons that are popping up, this is information from aviation SIGMETs, significant meteorological events. So most of the time it's turbulence at like 20,000 feet, but a lot of them are relevant to observatory level. Strong winds, storms, dust storms, lightning, etc. So we ask them as well for an extra layer of safety on top of just the wind, the rain that we can get from normal weather stations and forecasts. Here's a better IR clouds. You see there's some very dense cloud there, which is probably related to this rain, and a lot of high cloud as well. So the other thing I'm talking about forecast. This forecast here is made out of multiple, we use up to 10 different weather APIs that predict the weather according to satellite and local data. And so by combining all of those 10 data sources together about the weather, this is always very accurate. I would claim it's the first accurate weather system on planet Earth. But it's mainly because if you look at each weather method of prediction, each of them has their own assumptions, uses different data. But once you've got 10 and you medium them together, you get pretty close to the right answer. It's sort of like a wisdom of crowds thing. But each individual weather prediction has a 10% or 20% chance of being entirely wrong. But that gets ironed out. So that's quite cool. And that's the basis of much of this. And much of the local on the fly, on the spot weather prediction too. So where are we here? We are, whoa, yucky. So this is in California. This is one where it's just bad all night. So roof will keep the we'll keep the roof shut at this point. Why would you not open there? Is a good question. Oh, rain. So rain is forecast. So it's never going to open up if there's rain on the forecast, basically. Although, why would there be no rain and clouds? It's a question to be asked. But it's keeping it safe. If there's rain on the forecast, it's not going to open. So pretty much red across the board. That is terrible weather for California at this time of year. Mostly clouds, but obviously some rain. And you see the humidity is high here. Of course, when it's raining, the humidity is very high because there's water coming out of the air and hopefully not dropping on your telescope. Lots of clouds around. This is very irregular for California, but very good for me explaining things. Not too much rain on the microwave radar. Bit of rain from the ground radar up in North California. You've got some SIGMETs going on up here. The site is pretty safe, but you can see lots of clouds. No point in opening up. Why even bother? So who have I got next? Okay. This is another variable site down near Melbourne. So you can see, as I was saying about Melbourne before, you get patches where it's shut and then patches where it's clear. So this will actually open the roof for about 4 hours in the morning to get some data, according to this weather report. And by now you're used to those charts. We'll just have a look over here. Lots of rain. So this is the satellite rain detector thing. So these maps get analyzed, and if rain is within a certain distance of where your observatory is, it will shut up and it won't open up for another 45 minutes, but it will always keep on checking if there's rain there and keep on delaying the opening until such time it's 45 minutes after it stopped raining. Whew. Fun. So lots of rain coming through Bass Strait. I grew up down there. There's Lots of meteorological stuff. We had huge rain and storms earlier today. There you go, clouds. Last one, New Mexico. Oh wow, this is really good for me, but terrible for observing because I get to explain things. So, horrible weather, lots of cloud. I really would like some lightning strikes, for an example. I'll pull one up. So here's an interesting one. This is from sometime. Big rain coming through. See these dots here? That's lightning. So we have lightning detection that comes through. If lightning gets anywhere near your observatory, it will shut up and do the same thing. Wait for 45 minutes before opening again. 45 minutes since the last lightning strike within a danger radius. So here again in Australia, similar thing. Storm front coming through, lightning striking near the observatory, and that would force the observatory shut. So as you can see, we have a fairly sophisticated weather system to protect your observatory. It will keep itself shut in all but useful, safe conditions. The weather system also, it opens and closes the roof for you as well, but it also, if you have a dome, it will control the dome as well. And there's interplay between the dome software, our dome software, and the telescope, so that the dome isn't slave to the telescope. The dome actually proactively goes to where the telescope's going to go to, so you don't get this kind of race for the dome to chase the telescope around. The dome just goes to where the telescope's going the quickest way it can, and the telescope goes whichever way it wants to. So that's our weather system. It's pretty good.